Every second of every day, something incredible happens. Our planet is being bombarded. It is under a constant silent shower. This isn't rain or snow from our own atmosphere. It is something far more mysterious. Something that has traveled unimaginable distances to reach us. These are tiny particles, smaller than any atom. They arrive from the depths of space, carrying immense energy. We call them cosmic rays. They are invisible messengers from the great beyond. They tell stories of distant, violent events that we can only begin to imagine. They are whispers from the cosmos, carrying secrets of their birthplaces across the vast, dark emptiness of space. Think about the sheer scale of the universe. It is filled with stars, galaxies, and enormous clouds of gas and dust. It is a place of unbelievable violence and beauty. These are the kinds of places that could forge something as powerful as a cosmic ray. These particles are not just passive travelers. They are accelerated to nearly the speed of light. So how do we know these cosmic rays are even there? You can't see them. You can't feel them. They pass through our bodies all the time, completely unnoticed. Yet they are real. Their discovery was a wonderful story of scientific curiosity. Over a century ago, scientists were puzzled by a strange phenomenon. Instruments designed to detect radiation, called electroscopes, would slowly lose their charge. This happened even when they were carefully shielded from all known sources of radiation on Earth. But one Austrian physicist, Victor Hess, was not convinced. He had a different, more daring hypothesis. What if the radiation was coming from above, from the sky? In 1912, he decided to put his idea to the test. He took his electroscopes and boarded a hydrogen-filled balloon. As he rose higher and higher, away from the Earth, he expected the radiation to decrease. But he discovered the exact opposite. The radiation became stronger the higher he went. He had proven it. Something was raining down on us from space. This unseen rain of energetic particles was a revelation. It opened up a brand new window to the universe. We were no longer just looking at the cosmos. We were a part of it, constantly interacting with its most energetic creations. For this groundbreaking discovery, he was awarded the Nobel Prize in Physics in 1936. His bold balloon flight was a perfect example of the scientific spirit. Most cosmic rays, as we have seen, have a home. We can explain their existence. But there is another class of particle altogether. These are the ultra-high-energy cosmic rays, or UHCRs for short. The most powerful machine we have ever built on Earth is the Large Hadron Collider at CERN. Yet the energy of a single one of these ultra-high-energy cosmic rays can be 100 million times greater than what the LHC can achieve. One of the most famous of these particles was detected back in 1991. The energy of this single particle was so immense that the scientists who found it could hardly believe their readings. They nicknamed it the "Oh my God" particle. This is where the mystery deepens into a true paradox. There appears to be a cosmic speed limit, a barrier that should prevent these particles from traveling very far at all. This barrier is not a wall, but a fog. For an ultra-high-energy cosmic ray, the cosmic microwave background is like that treacle. The particle collides with the photons of the CMB, losing a little bit of its energy with each collision. Yet, we detect them. We see these ultra-high-energy particles arriving at Earth. We have a particle that shouldn't be able to travel far, arriving from a place with no apparent source. Hunting for ultra-high-energy cosmic rays is honestly one of the most challenging detective stories in all of science. When a high-energy cosmic ray from space hits the top of the atmosphere, it collides violently with the nucleus of an oxygen or nitrogen atom. The result is a vast expanding shower of billions of particles that can cover several square kilometers by the time it reaches the ground. It is an atmospheric firework display happening invisibly above our heads all the time. So how do you catch a ghost? You build a giant net. Modern cosmic ray observatories are some of the largest scientific instruments on Earth. The undisputed king of cosmic ray observatories is the Pierre Auger Observatory. Located on the vast flat plains of the Pampas in western Argentina, it is the largest cosmic ray detector ever constructed. It covers an area of 3,000 square kilometers. Dotted across this immense expanse is the surface detector array. It consists of 1,660 individual detectors. Surrounding this vast array are the observatory's other eyes, the fluorescence detectors. These telescopes only operate on clear, moonless nights, watching for the faint ultraviolet glow of air showers. This is where we come to the most mind-bending possibility of all. What if these particles are not from our universe at all? This idea comes from the frontiers of theoretical physics, particularly from string theory. String theory suggests that our three-dimensional universe might be just one brain, like a single sheet of paper, existing within a higher dimensional space, often called the bulk. If a very high-energy event happened in a nearby universe, it could be powerful enough to send a particle leaking or tunneling across the dimensions. This particle would then appear in our universe, seemingly out of nowhere. This would elegantly explain the GZK paradox. The cosmic ray wouldn't have traveled a long distance within our universe, so it wouldn't have been slowed down by the cosmic microwave background. But the source itself would be completely invisible to us because it exists in another reality. The gun that fired the bullet is not just in another town, it is in another dimension entirely. There could be a knock on the door from the universe next door. A hint that reality is far larger, far stranger, and far more wonderful than we have ever dared to dream. After decades of patient observation, the giant eyes of our cosmic ray observatories have gathered a wealth of data. One of the most significant recent breakthroughs has come from the Pierre-Auger Observatory. They discovered that the arrival directions of the most energetic cosmic rays are not completely random. There seems to be a slight preference, pointing towards a nearby region filled with starburst galaxies. The quest is far from over. The Pierre-Auger Observatory is undergoing a major upgrade called Auger Prime, designed to improve the observatory's ability to determine the mass of the incoming cosmic rays. Furthermore, the search is expanding into a new era of multi-messenger astronomy. This means combining information from cosmic rays with signals from other cosmic messengers, like gravitational waves and neutrinos. In 2017, IceCube detected a high-energy neutrino and traced it back to a specific flaring supermassive black hole. This was a landmark discovery. The ongoing search for the origin of cosmic rays continues to push the boundaries of what we know and what we can imagine. The next time you look up at the night sky, remember what is happening unseen above your head. Remember the constant, gentle rain of particles that have traveled for millions of years to reach you. This quest is a testament to human curiosity. It's a story about our innate desire to understand our place in the cosmos. So, I invite you to keep wondering. The cosmos is vast, and our journey of discovery has only just begun. The universe is full of mysteries, and the search for answers is the greatest adventure we have.